Hello everyone, I'm Sijali. Today I'm going to share our group project, Emulating Spark RDD API in Python. Our group members are Sijali, Yuanye Jiang, and Jiajin Xie. Next, I will introduce from the file 5 aspect, project introduction, project framework, code implementation, live demos, and summary. First, I'd like to describe our project background briefly. As we all know that the Spark is a tool for large-scale data processing with built-in modules, including the embedded use of SQL, stream data processing, machine learning algorithms, and the processing of graph data. The Spark is based on Hadoop's MapReduce algorithms to implement a distributed parallel computing framework that can help users process big data easily and quickly. One important object of Spark is RDD, the Resilient Distributed Dataset, where data are divided into partitions and operations are provided to support the common data processing. As we have learned in class, this picture shows the framework of the Spark context. We can see that after an application is submitted, the driver programs create a Spark context and acquire the resources from the cluster manager, who will start the executor process on different work nodes. Then the executors will send the response back to the driver programs. In our project, we use the HTTP libraries to emulate the message communication and coordination between the Spark context and the work nodes. In the next, I will introduce our contributions in our project. First, we emulate the Spark context with basic functions, including creating an RDD from a file or a Python list, dividing the dataset into the specified number of partitions, and supporting the major operations like map, filter, reduce, and collect. Second, we develop a class RDD which can check the locations of partitions in work nodes. The RDD also includes an iterator-like interface to implement the pipeline of data from one RDD to another. Third, we develop a class scheduler to send tasks to work nodes, coordinate with executors, and fetch task result by using the library GEO. Finally, we develop a web app to monitor the Java progress, submission time status, and the duration times. Next, I will introduce the code implementations with more details. The structure of our Python file is organized in this figure. The emulated Spark.py includes three main Spark classes, SC, RDD, and the scheduler. We have two work node py files, and they emulate the work nodes in Spark. For the job.py, it creates a Flask web server, and the job.json file stores the data that we needed. In class SC, its function is to emulate the Spark context. The function parallelize list and can create an RDD from a Python list, and the function parallelize files can create an RDD from a file. For the class RDD, we define three attributes: partition, schedule, and the locations. Here we use the partitions to record the partitions of RDD. And for the schedulers, we built in the class scheduler, which we will introduce in the next. And for the locations, it is responsible for checking the locations of RDD, and that is to say in which work nodes. Besides, we also implement the operations map, filter, reduce, and collect. The locations of the RDD can be achieved by the function getLocations, and we also design the function liters to implement the literator-like interface for the object RDD. The class scheduler is responsible for the message communication and the coordinations between the Java programs and the executors in worknodes. Here we can see that we use the request libraries for the data storage and the transfer. Next, I will introduce how to run our programs and create an instance to test our code. First, in the terminals, we start two worknodes in our terminals. After running these two files, we can see that we have two worknodes. One is running on the port 8000 and the other is running on the port 8001. This is our test files, and we can see that we have two worknodes. One is to 8000 and the other one is 8001. First, we generate a Python list 0 to 10 with two partitions, and then the data is sequentially passed through a map operation that multiplies by 3 times, a filter operation that filters the even numbers, and a reduce operation that adds them together. We also read the content from the file test file.txt. And for the test file.txt, the data is filtered sequentially by filter operations for the streams whose length is longer than 14, and the reduce functions for the streams to add them together. Here we run our code. The status code 200 means that our collector built successfully. And we can see the list are divided into two partitions. This is a result after the map operations, and this is a result after the filter operations. We can get the final result in the 60s, and this dict is the locations of our partitions. 0 means this partition is on the worknode 0, and 1 means that the partition is on the worknode 1. As for the result for the files, we can see that after the filters, we get the result as below. And finally, we can see that all lines with more than 14 spaces are this one. And the RDD partitions for these files is in these lines. This is all the result after we test our code. In the next, my teammate will introduce more details about the worknode.
Okay, let's continue our project on worknode. Regarding worknode, we decided to use Flex server to emulate them. At first, we create a Flex application instance and then define 3 functions which will be executed in worknode, like map, filter, and reduce function. To be continued, we have to specify the root path and allow HTTP method for the following execute task function. In execute task function, we first get the raw data from the request and deserialize the request data using deal to capture operation function and partition. Then, according to type of operation, we generate a result and then serialize it and return it as the HTTP response. Finally, we run the Flask application on port 8000 to create the work node. And we can also change port number to be 8001 or whatever, just to creating just to create another work node. Okay, let's continue. For submitting job and checking status, at first we have to import class SC, class RDD, and class scheduler from a previous PI file, and we're gonna create a new Flask application instance and initialize the SC, just a Spark context and those job here, and for those job and the write jobs, we use the load job and save jobs function. Then we're gonna, moreover, we define the root for index for index.html, which renders an HTML template, and also the root for submitting new jobs, which will be created in the following. Yeah, we also define the root for checking status and of the submitted jobs based on job ID. Furthermore, we define function submit code to submit the new submit job to submit the new job we generated. Firstly, we add a new job into the new jobs dictionary with status, submission time, and the duration, and we save it. Inside the submit job, we have the run jobs to generate a new job, like like what I show in a screenshot. It's gonna to calculate sum of the even number from 0 to 27 is a kind of job, and then we return a JSON. And in code show. Also, we create a new thread to run function or function run jobs so that the jobs are executed asynchronously. Then codes are followed by function job status, which aim to retrieve job information from dictionary jobs. If the job exists, return the JSON response. Otherwise, an error message is returned with 404 error code. Finally, we run the Flask application in debug mode. Then I'm gonna show how does it work. Like for in order to just submit the job of one, we have to type Python job1.py. Then we're gonna press the HTTP. We're gonna show when we click submit button, we're gonna show the job is in progress submitting. Wait. Okay, and the job one submission is completed, and the duration is 12 approximately 12 seconds, and the submission time is here. For after we submit the job one, we're gonna exit it, type Control and plus C, and we're gonna submit another job, just job two. Let's click the submit job button. It's gonna show the second job submission is running. Stated code is 200. It means successfully submit. Okay, the second job is completed, submitted. The second job submitting time and duration is approximately 8 seconds. Okay, I will let my teammates to show how web UI works.
Hi, thank you everyone. Thank you for joining me today as I present an interactive web application called Job Table Management System. This application allows users to track and monitor jobs as they progress through the various stages from submission to completion. The purpose of this system is to provide users with various interfaces that enable them to easy to manage and monitor their job submissions. The application is written in HTML, JavaScript, and CSS. Firstly, I would like to discuss the layout and design of this job table management system. The application features simple and clear interface with assist of the title, a table, and a few additional elements that display user and system-related information. The table is designed to hold information about each job submission, including the job ID, job status, and the submission time and duration. To submit new job, we just simply to clear this bottom and we just go. We already submit. And a new row to add to the table and job status is set quit. And application then monitor to progress and each job submission and update the table accordingly. As you guys can see in here, I also add a background for UIC titles. We have a job table and users call us name, and also I create a total uptimes. So once you open this up, once you guys open these applications, you guys will see the time is gonna be adding up. And also I have the scheduling models called the first in, first off. Also here, we have the active jobs. As my previous teammates present, if you click this bottom, you guys will have all the information, job ID and the job status, submission times, and the duration, how much money they spend. In the second part, I will explain how the things work in our code. So this is a very important coding. This part of the code is JavaScript function submitted job. It is used to send a post request to the backend with the URL set to the submission job. That job is being submitted. We use the fetch API to send the request and set the request method to post when the request is succeed. And also in this part is also JavaScript function is called monitor job. It uses monitor and the status of job with given job ID. First, the job function that is called and table row and correspond to the status, submission time, and duration of the job. Then it send get request to the backend with the URL job status followed by the job ID. This API endpoint is used to the status, submission time, and the duration of the job. The response from the backend is to press as the Java data and the status, submission time, and the value are from the data. Finally, I would like to share some of the learning experiences. So our learning experience in this project is which spent a semester are twofold in coding practice. We learn about the front to end and back to end interaction, which was a first for us. By emulating the Spark's API used for Python, we have deeper understanding of this principle framework behind the Spark, especially the coordinations between the drive program and the worker nodes. At the same time, we also met some of the challenges. Since Spark was tough in the last 2 weeks, we have to spend a lot of time on self-study in the advance because this was our first time for the team member to write from front to end. It took a long time to learn the HTML language. Also, we don't learn about the web UI. Everything we created for web UI is our self-starting. Well, thank you guys for listening.